Welcome back to Basic Biostatistics 2 to Session 7 and the first of 2 videos. In this session, we're going to discuss correlation analysis. I'm going to explain you how to run correlation analysis and SPSS, how to interpret the findings, when to use Pearson correlation coefficients, and when the one from Spearman. Sometimes we would like to know whether two continuous variables are correlated with each other. Correlation is usually measured with a correlation index R or correlation coefficient R, and we can measure either Pearson or Spearman correlation coefficient. The coefficient usually is between -1 and +1, whereas values between 0 and 1 means a positive correlation, so if one of the variables increases, the other increases. Values between 0 and -1 are inverse correlation, meaning that if the values of one variable increases, the other decreases. 0 basically means no correlation. The closer the values are to 1 or -1, the stronger the correlation. However, even if we observe a strong correlation, we still do not know if that correlation is statistically significant, so we need p-values. Let us have a look at a practical example. In our set of data, in our Dwarfs-Sander class, we would like to know whether age and diastolic blood pressure for month 1 are correlated with each other. The null hypothesis, as usually, is there's no correlation between age and diastolic blood pressure of month 1. In order to run correlation analysis, we go to Analyze, then we have further down Correlate. We go to Correlate, we choose Bivariate because there are two variables like to correlate. We click on Bivariate and a very simple window opens. Here, as usually, move age as a variable and diastolic blood pressure of month 1 to the window on the right side. That means the variables we've selected. If you click on options, you see you can ask for means and standard deviations as well of the different variables. You can select it just to see what you get out of it. Click on continue. Now, as I mentioned you, there are two sorts of correlation coefficients, Pearson and Spearman. If one of the two variables is not normally distributed, we need to use Spearman correlation coefficient, that is for not normally distributed data. If both variables follow a normal distribution, as in our case, we know that age and diastolic blood pressure for month 1 follow a normal distribution, we have to select the Pearson correlation coefficient, that is for normally distributed variables. So one more time, if one or both of the variables do not follow a normal distribution, use Spearman, otherwise Pearson. All tests are usually two-tailed, do not change anything here, and once you have programmed that window, we click on OK, and SPSS calculates you the correlation tests. As usually, receive first a descriptive statistics, the age of dwarfs, and diastolic blood pressure. As we selected the mean and standard deviation, we got the corresponding values. There's no missing observation. We have 60 observation in both categories. The important table is that one, the correlation table. As you see, you get a 2x2 table. What SPSS does, it correlates the two variables. It first correlates age with age, as it's a perfect correlation, it will be 1, and it doesn't calculate the p-value. But then it has the correlation between age of dwarfs with diastolic blood pressure to see in that square in the table. You have the correlation coefficient is -0.13. That means that for an increase in age, diastolic blood pressure decreases. However, if I have a look at the p-value is 0.920. That is way above 0.05. This means we accept the null hypothesis and we state there's no correlation between age and diastolic blood pressure. You see here we have the correlation with diastolic blood pressure with age. It's exactly the same. And then again, the last quadrant, we have like diastolic blood pressure with diastolic blood pressure. That is logically 1. You see, it's that simple to run correlation analysis in SPSS. When we go to logistic regression, I'm going to tell you why this is so important to know whether two variables correlate with each other or not. Usually the assumptions are that the correlation is linear We have no way finding this out without doing regression analysis or to check further the variables. Anyway, for our purposes, it was important that you know where to run correlation analysis and how to interpret the findings. In case one of the variables is not normally distributed, use the Spearman correlation index, and the program will tell you then here, instead of Pearson, it will tell you it's a Spearman correlation coefficient R. Thank you very much.